Starting with the name of Allah, the most gracious and the most merciful. In the last video, we have gone through TCP services. Now, in this video, as I told you, okay, I'll be dividing the TCP all content into the parts, into multiple parts. So, in the first part, we have gone through TCP services. In this part, we will be studying, we will be looking into the TCP features and the segments. So, I'll cover two parts in this video. So let's start with the TCP features. So as you know, Beta K, in order to provide services that we mentioned in our last lecture, TCP has to follow, have to keep with several features that are important in order to provide the services that we have just mentioned in our last lecture. So we'll go through these services in this section, in which the services are numbering system, flow control, error control, congestion control. You might have studied these three services: flow control, error control, and the congestion control. We might have gone through uh, multiple time the introduction of each layer. What is the function of data link layer, transport layer, and network layer? So whenever we discuss the functionality of each layer, these three functions are always discussed. So you might have gone through the functionality of the features, these three features. Our important concept is numbering the system. You might have gone through this numbering system, or you may, one of you who keeps interest in studying computer network, he might have explored uh, this numbering system feature of TCP. So let's begin with this numbering featuring this feature, numbering system, or how a numbering system is a feature of a TCP IP. The TCP software always keep a track of the segments that are being transmitted or being received. But actually the problem is, we need to include a separate data field in a segment, which keeps the record that this is a segment number one, this is segment two, this is segment three, and segment four. But unfortunately, we do not have a such field for a segment number. Instead, we have two different fields. Those different fields are sequence number and acknowledgement number. The first one is a sequence number, and second one is an acknowledgement number. So the bytes of data being transferred in each connection are actually numbered by the TCP. So the numbering starts with an arbitrarily generated number. So here it's talking about connection. So we'll study, okay, how actually a TCP connection is established, and how it start communication. And after establishing a connection, after it is done with our communication, it terminates its connection. So we'll discuss this connection part in our upcoming lectures as well. But the main important point is that I was discussing TCP includes the numbering system includes two different fields. The segment has two different fields. The first one is sequence number and the acknowledgement number. Now the main question is that it's saying that in the slide, it's saying that the bytes or data that are being transferred in each connection are numbered by the TCP. Now the question is how TCP numbers each data bytes. So whenever it has established a connection, how it numbered each each bytes in this TCP connection. So see, TCP actually TCP numbers all the data bytes that are transmitted in a connection. So numbering is actually independent in each direction. Whenever TCP receives bytes from a process, what is the process? Process is the application layer. So whenever TCP receives bytes, or you may say data, whenever the TCP receives the data from a process, from the application program, TCP is always going to store them in the buffer. So in the last video, I told you about the buffers. So TCP, whenever is going to receive the data from your application program, it will store the data into the sending buffers and then numbers them. So after storing the data into the buffers, it will number them. Now the important question is, is this numbering is done with a regular pattern, or is there is there a certain set of rules by which TCP numbers these data bytes? So the numbering doesn't necessarily start from the zero. Instead, the TCP actually chooses an arbitrary number ranging from 0 till 2 to raise power 32 whole minus 1. 2 to raise power 32 minus 1, as we'll look into our upcoming in our upcoming slides. Why I'm saying 2 to raise power 32, it has a reason. So for example, let me give you an example. Let's say the starting number happens to be 2000, and we have total 7000 bytes. So we want to transmit these 7000 bytes, and we say, okay, we'll divide these bytes into seven parts or five parts. Then we'll keep on counting. We'll say, we are actually numbering our data bytes with 1000, and then we'll be doing more. So let's look at the more clear example what I'm saying to you. So I hope you are clear. Okay, whenever TCP is going to receive a data, it's going to first of all store in its buffer, and then it will mark the data bytes with a specific numbering. And for the numbering, it doesn't has any rule. It always going to start with an arbitrarily generated number, but the number will always lie between 0 till 2 to raise power 32 minus 1. So it will always be in this range. So keep remember this. So let's look at the example beta in this regard. So suppose we have established a TCP connection, and we are transferring a file of 5000 bytes. We establish a connection, TCP connection, and we are transferring a file of 5000 bytes. So as I told you, okay, your first byte, the numbering always start with the first byte. So your first byte is going to be marked with a randomly generated number. It obviously it will be a ranging from, it will have a specific range, but it's going to be marked a specific number. It will always be visible to you. The examiner will always let you know, okay, what's the starting number. So it's asking what are the sequence number for each segment if the data are sent in five segments, uh, each carrying 1000 bytes. So it's sending total five segments. It is starting from the bytes 10,001. So this means your first sequence number will be 10,001, and then you have to add 10,000. Then you will have to add 1000 bytes in it, and you have to keep on adding 1000 bytes till you are completed with your five segments. So segment 1, segment 2, segment 3, segment 4, segment 4. In the first segment, you have to send total 5000 bytes. Your first segment will have a byte number 10,001. So the sequence number will be 10,001. And then I'll let you know, okay, why I'm using this term as a sequence number. This sequence number is also very important. So your segment one, actually your sequence number is always the number of your data bytes. So I'll explain you this term, K, why the sequence number is always going to be the data byte number. So the numbering that you have done is going to represent the sequence number. So here, let's first finish this example, then we'll discuss about the sequence number, and then we'll clear ourselves in a better way. So beta, your first byte is going to be 10,001 in the first segment, and it is given that, okay, we have to send total five segments. So we'll send our data in five segments. So number segment first is going to be include with the first byte, and the first byte is going to have a number 10,001. So second byte, what's the second segment? If we send our data in the second segment, so in the second segment, our number is going to be as will as our segment will be carrying 1000 bytes, so our number is going to be 11,001, and then similarly 12,001, 13,001, and 14,001. So let's look at the sequence number. So sequence number beta, after the bytes have been numbered, TCP assigns a sequence number to each segment that is being sent. So what is a sequence number? You may say sequence number for each segment. Keep remember this statement. Sequence number for each segment is the number of the first byte of a data carried in that segment. This is very important. This is very important statement. Okay, once the data bytes have been numbered. Once the data bytes have been numbered, how it is numbered? You remember that the process transferred the data to the TCP. TCP, after receiving the data, store it into the buffer and then mark the data bytes with an arbitrarily generated number. After marking the number, the TCP assigns a sequence number. So sequence number for each segment is assigned. So what is a sequence number? How do you assign a sequence number? Actually, a sequence number is always assigned with the number of the first byte of a data. That's why in this example you are seeing that your segment data, your sequence number and the segment data bits are both are the same. Both are the same. So that is the reason. That is the reason the sequence number for each segment is the number of the first byte of the data carried in that. That's the main reason. So the most important thing that we have left is about the acknowledgement number. So we'll discuss an acknowledgement number, but just keep remember about this segment number. Segment number is just the number of the first byte. It is always assigned with the first data bytes of your segment. So sequence. That's all about the sequence. So acknowledgement. Then our next data field is going to be the acknowledgement number. So, beta, as we know that TCP, as we have studied, is one of service. It's actually full duplex. So full duplex means whenever a connection is established, the both parties, the sender and the receiver, exchange the data at the same time. So this is the meaning of the duplex. So each party, the sender and the sender and the receivers is going to mark the bytes. So sender is sending the bytes, sending the data to the receiver. So sender has numbered its bytes. Similarly, uh, a receiver is sending the data to the sender. So a receiver will will have to mark its data bytes. So usually it's not a compulsion, but usually the sender and the receiver both parties mark their data bytes with a different data bytes number. They usually mark the numbers with a different data byte number. So the sequence number in each direction. So in each direction, either we are going from the sender to the receiver or receiver to the sender. The sequence number in each direction will be showing the number of the first byte that is carried by the segment. So now the next question is that beta how we are going to get an acknowledgement. So each person on the sender on the receiver will also be used an acknowledgement number. It will also have to acknowledge to confirm that either the sent bytes has been received or not. But the problem is that the acknowledgement number defines the number of the next byte that the party is expecting. So the acknowledgement number is actually the accumulative number. So just remember that the acknowledgement number is just a cumulative number. It's just a number that is cumulative. This means, beta, the sender or the receiver just takes the number of your last byte it has received, and it saves it and adds a one to it and announces the sum as the acknowledgement number. What does it do? It actually it takes the number of the last byte. As I told you, acknowledgement number will is going to be the number of your last byte. It going to and last byte will be the number of your will be your sequence number. So acknowledgement, how you are going to get an acknowledgement number? As I said, okay, it's an accumulative. What you are going to do, the sender or receiver, whoever is sending the acknowledgement, it's going to take the number of your last byte that has been received. It will save it, it will add one to it, and it will announce the sum as the acknowledgement number. So that's why I have used the term cumulative here. So let's say beta I'm a sender and I'm using an acknowledgement number 5000. I'm sending an acknowledgement number 5000. So this will means that I have received all the bytes till the 5000. That 5000 bytes. So all the bytes sent till the 5000 in the segment till the 5000, I have received all of the bytes. So I have received all of the bytes. So that's why in this here is saying that the value in the sequence number defines the number. I have gone through this part. So the value of the acknowledgement field in the segment defines the number. This part is also done. So the next part, the next, the next, the next thing are segments. So segment is also very important thing, beta. Okay, before we go into the more detail of the TCP, it's more important for us to look at the TCP packets. So, segments, what basically segment is. Before, I think before jumping into the segments, I haven't yet completed with the flow error. Okay, so flow error congestion, we have multiple time gone through these points, so I'm just leaving it to you. So let's move to the segments. So in the segments, we'll look into the formats of the segments and then the encapsulation. So this is the TCP segment format. Uh, we'll have to remember this TCP. So the if we look at the format of a segment, then it's clear that the segment actually consists of a header, and header is a 20 to 16 bytes. Then we have data. So this data is supposed to be from the application program. So the header, if the header is of 20 bytes, this means there are no other options are available. And if it's up to the 60 bytes, and then obviously there are going to be multiple options are available. So we'll discuss the header fields in this section, inshallah. So but just look at few of the fields of this header. So in the header, the very first part is source port address. So this is a 16-bit field. You have to just remember. You have to just remember about each of these fields. So source port address, as it's a name evident, okay, it will be containing the port number of the application program in the host that is sending the segment. You have to keep remember about it. Okay, source port address is the port number of the application program in the host that is sending the segment. Similarly, you have destination port address. This is also a 16-bit field that defines the port number of the application program in the host that is receiving the segment. Similarly, you have a sequence number, 32-bit field that defines the number assigned to the first byte of a data contained in the segment. You have an acknowledgement number. This is also a 32-bit field that defines the byte number that receiver of the segment is expecting to receive from the sender. So similarly, you have a reserved field. This is a 16-bit, 6-bit field that reserved for the future use. You have a control bit. So this field defines six different control bits, or you may say, okay, this field, this control field, this control, this control field, this control field. Actually, what it does actually it defines six different control bits or flags. One of these fields can be set at a time. So these are the bits actually enable flow control, connection establishment, and the termination, connection abortion, and the mode of the data transfer in the TCP. So we'll go through the description. So these are the URG, reset the connection, synchronization, sequence number. So these are the control bits that actually these bits actually enable the flow control, connection establishment, tier the connection, so some sort of these things. So similarly, you have window size beta. So this field defines the window size of the sending TCP in a byte. Similarly, the checksum is a 16-bit field that contains the checksum. The calculation is it's kind of a calculation. So these are the few fields that are very important. So similarly, the urgent pointer. This is an urgent pointer. So urgent pointer, you may say okay, this is also a 16-bit field, which is valid only if the urgent flag is set. As I told you, can while you may sometimes need to set your flag urgent when the segment contains urgent data. So so this is all about. So the last part is an option. So option, there can be 40 bytes on optional information in the TCP header. So beta our next and last part is the pseudo header added to the TCP segment. So this pseudo header TCP segment, uh, this pseudo header serving the same purpose as it does in other packets. So it is added to the segment for the TCP pseudo header. It has 32-bit source port address, destination IP address, 8-bit protocol, and TCP total length. So these are the few fields which are mentioned here. So in the last beta, the checksum in the TCP is very only the difference between TCP and the UDP is that checksum is mandatory in TCP, But in UDP, checksum isn't you may say कि it isn't necessary. So this is the encapsulation beta, which is a TCP segment is always encapsulated. So what does a TCP segment do? A TCP payload is encapsulated into the application layer, and then the application layer is encapsulated in an IP datagram, and then an IP datagram is encapsulated into the data link frame header. Data link frame header. So this is how original encapsulation is done. So I hope we are all clear till now about the TCP features and TCP services. So in the next lecture, I'll be going through the TCP connection beta. Inshallah, then we'll see how our connection is done. Till then, thank you so much.